Hello and welcome to 7.3 Notes. I just want to go over really quickly what an altitude is, an altitude of a triangle. So if you have a triangle, the altitude is defined as the line segment from a vertex perpendicular to the other side. Okay? So again, it starts from a vertex and it goes perpendicular to the other side. That's an altitude of a triangle. Basically, how tall that triangle is from this base to the vertex of the other side. Okay? So that's what an altitude is. And the theorem we're working on now is if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So if you have, for example, this triangle here, then this portion of this triangle, this portion of the triangle, is going to be similar to that triangle. So the little right-hand triangle is going to be proportional to the left-hand triangle, and the little triangle is going to be similar to the larger triangle, and this triangle is going to be similar to the larger triangle. Okay? So that's what I'm showing here. So you have triangle ABC, and then you have an altitude CD that's dropped perpendicular to the other side, and it's from the vertex to the hypotenuse, right? Because angle C is the 90-degree angle, so AB is the hypotenuse. So we have an altitude that's drawn from the vertex to the hypotenuse of a right triangle, right here. And so then the two triangles formed are similar to the original triangle and to each other. So I have this triangle, CDB, broken up and kind of moved over here. And then this triangle, ACD, is broken up and moved over here. And then you could see that triangle CBD is similar to triangle ABC. So the smaller triangle is similar to the original triangle. And triangle ACD, right here, is similar to the original triangle. And they are similar to each other. Okay? Okay, let's look at a typical problem you would get based on this theorem. Identify the similar triangles and then find the value of x. So first, let's identify the similar triangles. And to do that, I would travel around all three triangles by going first from the short to the long and then back through the hypotenuse. Short, long, hypotenuse. Okay? So on the large triangle, I would go, 3 is the shortest side, and then 4 is the longest side, and 5 is the hypotenuse, which is actually, of course, the longest leg of the triangle, but we call this short, leg, long leg, and then the greatest value, of course, is the hypotenuse. The greatest value of a right triangle is directly opposite the 90-degree angle, and it's not called the longest leg. This would be called the longest leg. It's called the hypotenuse, right? So that was just a little bit of review. So again, going along here, I'd go short, and then I would go, let me try this. I would go short, and then long, and then back up to the hypotenuse. So that would be EGF, right? EGF. And then for the next triangle, I would go GHF. This is short, long, and then back through the hypotenuse, right? This is the right angle. And then the next triangle would be EHG. This would be the short, this would be the long, and this is the hypotenuse. Okay? So we've answered the first part. We've identified the similar triangles. Now to find the value of x, we would use this proportion. The hypotenuse and long of this triangle, EHJ, is going to be in the same ratio as the hypotenuse and long of the original triangle EGF. Okay? So, moving right along, the hypotenuse of the small triangle is right here, 3. Let me change that. Is right there. That's 3. That's where you get the 3 from. And then the long side of this triangle is x, right? That's the long side. This EH would be the short side. So that's where I get 3 over x. It's gotten from the hypotenuse over long of triangle EHG. Okay? And then 5 is the hypotenuse of the large or original triangle EGF, right? And the 4 is the long side of triangle EGF. So those are all similar, so they should be proportional, and that's why we can set up this proportion. And then cross multiplying, we get 5x is equal to 3 times 4, or 5x is equal to 12. Divide both sides by 5, and you get your answer. X is equal to 12/5. So find the value of x, and there it is. The answer is 12/5. Okay, and I just noticed that at one point I inadvertently called this triangle EHJ. I said that only once, and of course I made a mistake. I meant to say EHG, so I'm sorry if that confused you, but that's my attempt at clearing it up. So EHG. All right, and moving right along, we have another problem. And find the value of y. Write your answer in simplest radical form. Well, we have a right triangle, and we have an altitude from the right angle to the hypotenuse. And it's an altitude because it's hitting at a right angle, right? So that the theorem applies. Let's see. Theorem 7.5 applies to this problem. So I know that this triangle is similar to this triangle. They're similar to each other, and they are both similar to the original triangle. Okay? So to solve this problem, I would create a proportion like this, and I would create this 2x2 grid, just to remember to keep me straight. So I make a proportion that works, a proportion that's valid, and not one that's wrong. Remember, we've gone over this in class a few times actually, that I would create this grid and use English words to keep me straight. So I have triangle, everything in the left hand ratio will be in relation to triangle RSQ. Everything in the right hand ratio will be in regards to triangle RQP. And everything in the numerator will be regarding the hypotenuse, and everything in the denominators will be regarding the short side of the triangle. So if you look at triangle RSQ, okay, that's right here. Hold on, let me try this. RSQ, okay. The hypotenuse of RSQ, well, if this is the right angle, then that must be a right angle as well. So the hypotenuse is right there. The hypotenuse is y. Okay? And then the short side of triangle RSQ, okay? The short side is right here. The short side is 3. And the hypotenuse of triangle RQP, so now we have RQP, and the hypotenuse is opposite the right angle, so it must be this whole length, which is 9. So the hypotenuse is 9. And then the short side of RQP is y again. So we have this as our working proportion. So moving right along, we have y over 3 is equal to 9 over y. And then cross multiplying, we get y squared is equal to 3 times 9. Take the square root of both sides and get y is equal to the square root of 3 times 9. Now, does that ring a bell? Okay, does this ring a bell? It should. It's the geometric mean. Remember, if you take two numbers and multiply them and then get the square root, you get the geometric mean. So some of these problems can be solved by using the geometric mean. Okay, so moving right along, y is equal to 3, the square root rather, of 3 times 9, so y is equal to, excuse me, the square root of 27. And then writing that in simplest radical form, the square root of 27 is equal to the square root of 9 times the square root of 3. The square root of 9 is 3, so the answer is 3 root 3. Okay, so that's the answer to the problem. Y is equal to 3 root 3. So that's the end of the lecture. If you have any questions or concerns, as always, please feel perfectly free to come see me, and I would be more than happy to help you. Okay, bye-bye.